In session 11 here, we're going to be taking a look at an introduction to functions. Before we go in to describe what a function really is, let's go ahead and take a look at an example, a short story problem that illustrates for us a function, and then we'll take a little bit deeper look at it. Here's the situation. A father wanted to help his daughter start saving some money. He made a deal with her that for every dollar that she deposited into her bank account, he would put $3 of his own money into her account as well. So then we have a relationship between the amount of money that the daughter deposits into her savings account, and there's a relationship between that amount and the amount that her father will also deposit into her account for her. Let's just go ahead and start choosing some different values, and that should help us start seeing what a function really is. For example, we have two items here. We have the daughter's money that gets deposited into the savings account, to the bank account, and then we have the father's money that gets deposited in. So let's assume for a moment that the daughter puts in $1. How much money then would her father put in? Well, her father would put in $3 because for every $1 she puts in, he's going to put in 3. Well, let's say he goes ahead and puts in 2, or excuse me, she puts in $2. How much is he going to put in? Well, he's going to put in 6. If she puts in 3, he's going to put in 9. If she puts in 4, he's going to put in 12. If she puts in 5, he's going to put in 15. And then so on. If she were to put in 20, he would put in 60. But as you can see here, that for every $1 that the daughter deposits into her account, the father is going to deposit 3. As we can see here, there's a relationship between the amount that the father deposits and the amount that the daughter deposits. And as we can see here, it's a very simple relationship. He's putting in 3 times as much as she's putting in. So we can go ahead and actually give an equation or assign a formula or an equation to this particular function. Our table here helped us visually see the function. We could just take a look at the daughter's money or the daughter's amount, look underneath it, and after a couple of times through, we could detect the pattern. And the pattern is that the father is depositing 3 times as much money as the daughter. So let's go ahead now and give this a formula or a function. So I'm going to go ahead and sign the letter F, and what F is going to represent is the amount of money that the father is depositing into the bank account. F equals 3 times D. D representing the amount of money that the daughter is going to deposit into the account. So then, we can actually take our values from our table here and start plugging them into this very simple formula. For example, once again, D represents the daughter's money. Well, let's take $1. Take this 1 and stick it into the formula here. What's 3 times 1? Well, 3 times 1 is 3. So when D is 1, what would F have to be? Well, F would have to be 3 times 1, which is 3. And we can see that that matches our table value up here for the father's money. Let's skip over to $3. If the daughter deposits $3, how much F is the father going to deposit? Well, D is 3. 3 times 3 is 9. So when the daughter deposits 3, the father will deposit 9. And we can see here underneath the 3 for the daughter that the father has deposited 9. And lastly, if we were to take a look at the 5, skip over to the 5 deposit. The daughter deposits $5. Well, when the daughter deposits 5, how much F is the father depositing? Well, he's depositing 3 times 5, which would be 15. So then, a very simple formula here that's outlining or describing this particular function. The function is F, the father's money, is going to equal 3 times the daughter's money. Okay then, that's a simple look at a very basic function. Let's go ahead and skip over here to the next screen. And we're also going to take a look at a very, very basic kind of a function here. And once again, we're going to start it off with a story problem, a very short story problem. Mary and her cousin Sam both have the same birthday. However, Mary is 2 years older than Sam. Right off the bat, you should see that there's a special relationship between Sam's age and Mary's age. And what we're going to see is that it's also a function. Now, let's go ahead and start assigning some ages. When Sam is 4 years old, now let me go ahead and erase that. Okay, when Sam is 4 years old, the question is, how old's Mary? Well, since they were born on the same day, Mary is always going to be 2 years older than Sam. So when Sam is 4, Mary is 6. Well, let's just skip and choose Sam being 11 instead of going 1 year at a time, which is it's actually easier to see the pattern that way. But let's just skip for a moment over to 11. If Sam is 11, how old's Mary? Well, Mary would be 13. And now let's just resume with the next sequential age. If Sam is 12, what would Mary be? Mary would be 14. If Sam is 13, Mary would be 15. Then if we skipped up to 52, Sam's 52, Mary is now 54. So you can take a look at this table here, Sam's age going across the first row, Mary's age going across the second row. And if you take a look at the first number and then compare the second number against it, you should be able to detect the pattern. The pattern is that the number in Mary's row that corresponds to the number or the age in Sam's row is always going to be 2 more. So then, let's go ahead now and create a formula that would represent this function. Okay, Mary's age is a function of or dependent upon Sam's age. So I'm going to go ahead and assign the letter M for Mary's age. And we're going to create a formula. What is the relationship between Mary's age and Sam's age? Well, Sam's age we're going to go ahead and represent with an S. And then we're going to add 2 to his age. So that at any given point in time, whatever Sam's age is, Mary's age is going to be 2 more than that. Well, let's double check this simple formula and see if it works. We've already outlined in a table form a function up here. Let's see if our formula for this function is indeed accurate. Let's go ahead and choose 11 here. If Sam is 11, how old's Mary? M representing Mary's age. Well, when Sam S is 11, 11 plus 2 would be 13. So when S is 11, Sam is 11, Mary is 13. And you can see here that when Sam is 11, Mary is 13. And we can do the same thing here with 52. When Sam reaches the age of 52, we'll go ahead and stick a 52 in here for S because S represents Sam's age. 52 plus 2 would then be 54. When S is 52, M would equal 52 plus 2, which equals 54. And we can see that that does indeed match the table that we have over here. So then, in this particular function, here's our formula, M equals S plus 2. We have 2 variables in this particular formula. We have the variable letter M, which represents Mary's age, and then we have the variable letter S, which represents Sam's age. Now, if you look at the root of variable, it's the word vary, and vary means to change. So a variable basically means that you can have changing values that you can place within it. That the variable does not always represent just one exact particular value. So, as Sam's age varies, Mary's age varies. As Sam's age varies from 4 to 11, Mary's age varies from 6 to 13. And if we back up to our previous example, our very first one, F equals 3 times D for the father's money and the daughter's money, we also have 2 variables, F for the father's money and D for the daughter's money. The father's deposit into her account is a function of the amount that she deposits. As the amount that she deposits varies, she deposits $1 to begin with, and then it varies. A little bit later, she deposits $4. As her amount varies, so does the amount that he deposit varies. That's what the two variables here indicate. Lastly, we can see that for every value that's in the daughter's money, that's in her row, that's in her set, there's just one exact value that the father deposits as well. So if the daughter deposits $4, will the father always deposit the 12? Yes. He doesn't deposit 12 sometimes and 16 another and 8 another, because based upon this story problem here, he is always depositing 3 times more than what she will. So for every unique value in her row, there is just one unique value in the father's row. That's a one-to-one correspondence, and that's what a function is. For every value in this row up here, we have just one unique value being assigned to it down here, and that's what a function does. Same here with Mary and Sam's age. For every unique or every different value up here in Sam's age, there's only one value beneath it to match it. That's a one-to-one correspondence. And as our review page here indicates to us, that is a definition for a function. A relationship between two sets of numbers such that for every unique number in the first set, there is just one unique number in the second set. Okay then, that finishes up session 11 on an introduction to functions.